The graphing part of the test is going to be no calculator, so you have to be able to do these problems all with no calculator. The first question here is in vertex form. So we're able to get the vertex straight out of the equation. Remember, like always, when we had parentheses, the number inside of that will be changing signs. That's the left or right direction for our vertex. So we're going to be making this be a -2, just like we did even when we had absolute value. When it was inside the absolute value, it was the left-right number and it changed the sign. So we have -2, and the y value, the value outside the parentheses, always will keep its sign. So remember, when it's inside, we're always going to be changing the sign when we take that out. So the vertex is at -2, -3. And I'm going to plot that. This sign out front is very important. It's a negative sign, so we're going to have a sad parabola. It's going to be going down. If it had a number out here, we would have to take that into account as like a stretch on our graph, sort of like a slope. I prefer to use the pattern method when I'm graphing my quadratics. It seems to be the easiest thing. The pattern that you want to use is if you're moving out 1, 1 squared is 1. If you're moving out 2, 2 squared is 4. If you're moving out 3, 3 squared is 9. This is how much you would move up or down when you move out these amounts. So I know I'm going to go down, and I know that as I go out 1 from the vertex, I'm going to go down 1 since it was a negative in front. So out 1, down 1. And then if I move out 2, I'm going to go down 4. This is the pattern method for graphing these. 1, 2, 3, 4. If you have trouble using the pattern method, you could always create a table of values surrounding your vertex. You would still find the vertex first, and if you were to do that, you would just like sketch a table here. You would put the vertex in the middle, and you want to surround that. 2 numbers to the left of it, and 2 numbers to the right of it, and then plug these into your equation and get your y values. But that's a lot of work when you can just use the pattern method to do that. So I really love this pattern method of graphing. So that one is done. They didn't ask me for the axis of symmetry, but if they did, if they asked me for the axis of symmetry, it's an equation, so always put x equals, and it's always x equals. It is always the x value of the vertex every single time. So here it's x equals -2 if they ask me for that. On the second one, this is in, what format is this? Factored form. You'll get your zeros out of, or your x-intercepts out of the factored form here. In this case, though, this is sort of the special case. When they're exactly matching, it means that we're only going to have one root here. It's a double root. When they have 2 matching like this, they call that a double root. And what you do is you can just do like I did over there, and you just change the sign on it. You would see that each of these is a value of 3. And what I'm really doing when I do that is I'm setting it equal to 0 and then solving. So that's how I'm getting the 3 there. And what that tells me is that that is where it crosses the x-axis. That is my x-intercept. So they wanted us to label the x-intercept. So here the x-intercept, there's only one. It is at 3, 0. Since it's a double root, that is also the vertex. So the vertex here is also at 3, 0. The axis of symmetry comes from the vertex, always x equals, and it's always that x value. So x equals 3. So all of that had to do with that value of 3. So I'm going to draw in my axis of symmetry here. And I'm going to plot my points. It has a 2 out front, which is going to be a stretch on my pattern values. It does not affect how far I'm going to go out, but it will affect how far up and down I have to move. So what I need to do is all the numbers from my pattern here, this 1, 1, 2, 4, 3, 9, the change vertically needs to be multiplied by 2 because of the 2 value out front there. So instead of, and it's a positive 2, so it will be happy going up. Instead of going out 1 and up 1, I need to go out 1, and then 1 times 2 is 2. So as I move out 1, I need to go up 2. And then as I move out 2, 4 times 2 is 8, so I'll have to move up 8 as I go out 2. So 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. It puts me off the grid. But I want to have as many as I can get here. So here is my parabola. And this green line is the axis of symmetry, which was at x equals 3. Here's the vertex, which we have at 3, 0. It's also the x-intercept. So that is question number 2.